Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. In this video, I am going to teach you a very good technique to find the relation between acceleration of different blocks in a mechanical system where there are multiple pulleys and multiple blocks. In this method, the basic idea is if you have a string which is straight or passing over a pulley, if the string is taut, work done by tension on both the ends of the string, the total work done is 0. Suppose consider this string, there are two ends A and B. At this end, if it is connected to a block or something, the tension is acting in this direction. At the end B, the tension is acting in the opposite direction because tension is always in the direction of the pull. Suppose if A moves by x units towards right, then B will also move towards B should also move x units towards right along the string. So the work done by tension T into x plus Tx, and you have a negative sign because angle between force and displacement is 180, so it is 0. So even if the string is passing over a pulley, so consider a simple upward machine. So this end of the string, it has got a tension T and the other end has got a tension T upwards. If the displacement of the block is 1 meter up, displacement of this end would be 1 meter down. So work done by tension is T into 1 minus T into 1, so this is 0. So the idea is total work done by tension is 0 at two ends. So the same thing we are going to apply in this particular method. So let us take a very simple example first, M1 and M2 connected with one fixed pulley and one movable pulley to find the relation between acceleration or velocity of M1 and M2. We can straight away apply the constraint method. I've already done that video and explained how to get the constraint equation of which relates acceleration of M1 and M2. So if you haven't watched it, I'll mention the link in the description. You can go through that. Now this is a shortcut or a technique to get the same constraint equation in a very, very simple manner. So I'll call it tension method. The main concept of this method is work done by the tension, the total work done by tension on all the blocks of the system is 0. So net force, tensional force T bar dot x bar, that is equal to 0. Suppose consider this a big string which is passing over this fixed pulley and the movable pulley. Say the tension here, it is T. Say the acceleration of M1 is A1 and the tension in the other string, let it be T1, which is equal to 2 times of tension T. So because this is T and T, so if you draw the free body diagram of the pulley, T and T is up and T1 is down, so T1 is equal to 2T. So on the block M2, the tensional force is T1, which is equal to 2T. So total work done by the tensional force on the system is 0. So in this case, say the acceleration of M2 is A2 up. For example, actually speaking, if M1 is accelerating up, then M2 should accelerate down or vice versa. I'll also leave that aspect to the final result because final result will tell you that acceleration's direction of M1 and M2 will be opposite. Now look at this, sum of the work done by tension at different points is 0. So if you differentiate this function, you get sigma of T bar dot dx bar by dt, that is 0. So if you again differentiate this function, you get sigma of T bar dot A bar, this is equal to 0. So this is the equation I'm going to use. If you have to find the relation between the velocities of M1 and M2, then you are supposed to use this second equation. Sum of T bar dot V bar is 0. Now the technique is this. So T bar dot A bar. So you have to also be very careful with the dot product of two vectors. A bar dot B bar is A into B into cos of angle between A bar and B bar, AB cos theta. So in this case, angle between tension and acceleration A1, it is 0. So T bar dot A bar becomes T into A. The next, at this on this block M2, so work done by tension is T1, which is equal to 2T. So plus 2T, because you have the sigma, sum of all the work done by the tension must be 0. So 2T into the acceleration here, it is A2, and the angle between tension and acceleration is 0. So cos 0, which is 1, that is equal to 0. So I get, so I'll write this as A1. So A1 plus 2 times of A2 is equal to 0. This is the equation. If A1 is A, if A1 is equal to A, then A2 is equal to minus A by 2. It means that if the acceleration of block M1 is A up, then acceleration of M2 would be A by 2 down. So that is the meaning of this minus. This minus is conveying that information. And it is so obvious, right? Suppose if M1 goes up by 1 meter, 1 meter, the 1 meter of string is given to the pulley, so half and half is distributed on two sides, and pulley will come down only by half a meter. So if the velocity of M1 is 1 meter per second up, then the velocity of the pulley would be half meter per second down. So similarly, if the acceleration of M1 is A up, then acceleration of the pulley or the M2, because pulley and M2 are connected with a single string, the acceleration of the pulley would be A by 2 down. So that is what we derived here. A by 2 is equal, sorry, A2 is equal to minus A by 2 if A1 is A. The constraint equation is A1 plus 2A2 is equal to 0. So let us apply the same method here. In this case, so I can take the tension to be T here and the tension to be T1, and here also it is T1. If you draw the free body diagram of the pulley, so T1 down, T and sorry, if you draw the free body diagram of this pulley, so you have T1 down on two sides and T up at the center. Because pulley is an ideal pulley, massless pulley, though the pulley is accelerating, net force on the pulley can be taken to be 0. So T is equal to 2T1. So T1 can be written as T by 2. So here it is T by 2. So consider the acceleration of M1 is A1 up, M2 that is A2 up, M3 that is A3 up. I'm not absolutely bothering about the respective directions of accelerations, because the final answer will tell me what is the exact direction of accelerations of M1, M2 and M3. Now apply this sigma T bar dot A bar is 0. So work done on M1 by the tension, that is T into A, because angle between tension and acceleration, that is 0. Okay, just if you suppose if you have taken the acceleration of M1 to be down, if the acceleration of M1 is down, if you have considered it to be down, say A1 is down and T is up, here you would write minus T into A1, for the simple reason that angle between tension and acceleration is 180 degrees. So cos 180 is minus 1. So but to keep it simple, I have taken A1 up, all accelerations in the upward direction, then T plus T into A1, then plus T by 2 into, I have A2, T by 2 and A2 both are in the same direction again, and T by 2 into A3, T by 2 and A3 again are in the same direction. So T by 2 into A3, so all plus, which is equal to 0. So I have 2A1, so I can multiply by, I can take T common and multiply by 2, so 2A1 plus A2 plus A3 is equal to 0. This is the constraint equation for this particular case. Now let us take another example. Take this multiple pulleys and two block system. I want to find the acceleration relation between M1 and M2, so I'll take this as A1, and I'll take M2's acceleration direction to be A2 downwards. Deliberately I'm taking down because I want to show you what will be the equation if the angle between tensional force and acceleration is 180, right? So now in this case, So tension T in the string, so you can take this as T and T and T, T, T. Suppose if you take tension in this string to be T1, T1 is equal to 2T. If you take the tension in this string to be T2, T2 is equal to 2T. Similarly, T3 is equal to 2T. Total 6T upwards is acting on this big block M1. So sigma T bar dot A bar is 0. So 6T is acting 6T into A1. Angle between 6T and A1 is 0 because both are directed upwards. And now coming to M2, it is the same string. It is a single string from this point passing over 3 pulleys and another one 4 pulleys. So 1, 2, 3, 4, 5, 6 pulleys. It is the same string which is passing over these 6 pulleys and connecting the M2 block. Now angle between tension and acceleration A2 is 180 degrees. So I would write minus T into A2. That is equal to 0. So 6A1 is equal to A2. This is the equation. And now if it is obvious that the direction of accelerations of M1 and M2 will be opposite. So I have assumed opposite and I got 6A1 is equal to A2. This is the relation between A1 and A2. So instead of applying constraints, instead of differentiating and double differentiating, this is a very easy method when you have multiple pulleys and block system. I hope you understood this. Thank you. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.